In this module, we will illustrate how to use the blob tool to inspect and locate parts. As always, the first thing is to ensure that we have a good image through the exposure and focus. To simulate this module, we will solve an application given to us by customer XYZ. Customer has 3 packets of pills. He wants to make sure that each of this packet has got a count of 12, and if there is any that doesn't have that count, they want to be notified using a digital output which packet it is, so they can route it to the faulty bin. Once we have a good image, we can teach reference object, which takes a snapshot from the live image and puts it in a reference image tab where we can go and teach. We will click on the blob tool and simply go ahead and draw it around the area of interest. The settings for the blob tool appear on the right hand side. The first one is in the intensity, although the blob tool is smart enough to start with very good settings for us. If I were to stretch this to the left, what I'm saying is find everything that's pitch black between 0 to white, that's 255, and that's highlighted in red right now. And it's failing because there is a minimum and maximum area that has been allowed over here. If I stretch the maximum out, it will find everything in that view. But we are interested in simply finding the pills. So if we adjust our settings accordingly, we can look at the results parameters that there are 16 blobs that are being displayed. However, there is really no information on the last 5. That's because only 11 blobs are found. The blob tool is capable of finding maximum of 16 blobs. But for the ones that are found, we will notice that the area, we have an X coordinate, a Y coordinate, and an area, and the area is descending because inside the tool itself we are sorting them by area. We can choose to sort them by any other position. So when we look at the area, it goes between 450, which is the biggest, to 390, that's smallest. To make our application more robust, we can limit the maximum area so that we don't find anything other than the pills. Once we are happy with all those settings, we can simply copy this and paste it and move it over, and we can do the same thing, copy, paste, move it over. So now this is blob 3, this is blob 1. So what I'm going to do is, to make this more logical, I'm going to move blob 2 over here so we have everything in order. Remember, we are assuming that the part presentation is reliable, so these 3 packets are going to be appearing in the same position every time, and there is a trigger sensor that's telling the camera when to take snapshots. Finally, once we have these 3 inspections, each of them is giving us a pass right now, although this one has got 11 blobs assigned to it. So what we need to make sure that for each of the blob tool, we have this number of blobs parameter. We want to make sure that parameter is set to 12, because that's how many pills we expect for each of the tools. So I'll do the same thing for blob number 2, and that immediately fails, and I'll do the same thing for blob number 3. Okay. However, they are all assigned to the detail inspection tool right now. That's why we see that output number 2 is failing, because that's how output number 2 is configured. So what we need to do is we need to assign each of these digital outputs to each of the blob tools. So we can click on edit expressions, and we can add a new expression, and we'll call this left blob, and we'll have that assigned to blob number 1 for fail. So now we can go ahead and allocate left blob over here. Similarly, we can go edit expression for a new expression which we can call middle blob, and this one can be assigned to blob number 2, fail, and we can add one more, the last one, which is right blob, which we will assign to blob number 3, again fail. So now it's a matter of simply assigning the outputs to the appropriate tools we just created, and now we notice that output number 2 is high, output number 1 and 3 are low because they are pass. However, if I move this around, now you see that the two other outputs are failing because the middle one is the only one which has a count of 12. So should there be a variation in orientation of this, we can use the object locator tool to first locate the edges of the blob, so the boundaries are going to be located, and then the blob tools are going to be applied with reference to how the boundaries of the blob tool are located. Now even if I move it around, what happens first is my object locator is locating where all the pilled packets are supposed to be, and my blob finder tool are then being positioned accordingly. You can also communicate the blob count number as well as all the position and area information for each of the blobs, for up to 16 blobs for each of them, via Ethernet or Ethernet IP. However, this subject is going to be covered in a separate video that has to do with communicating data via Ethernet.